Alright everyone, I'm going to be giving you a little bit of a run through on how the portfolio optimization code actually works. So actually it's not an exact portfolio optimizer because it takes a look at past data and analyzes which of the best portfolios to have during that time. But we can easily apply this to real-time data if we really wanted to. Anyways, let's take a look at some of the code in this portfolio optimizer so far. So of course, the user has to put some input here to get the number of tickers they want to have, and then they have the number and they have the actual tickers which they can input through this input here. And then you're going to make a data frame which basically takes all of the tickers you have and uses the Polygon API to take the information from that ticker, and basically it puts it all into a data frame so it's easier for us to work with. And once we concatenate all those data frames together, we're able to go to the real part, which is the more important part of the actual code. So the first part is actually getting the return volatility and the Sharpe ratio of this particular function, of this particular portfolio based on the weights you give it. So I'll explain a little bit more about this later, but in essence what it does is it gets the return through the sum of the logarithmic returns, which is basically just returns but expressed in a more better way. And then we have the volatility, and then we have the Sharpe ratio. The Sharpe ratio is basically just an analyzing of how good a stock is based on the risk it has. So basically the return based on the volatility. And this is a really good indicator for investors to choose which stocks they should invest in, because a bigger Sharpe ratio would mean that they get more returns for a specific amount of volatility, which is good. So then obviously we return this numpy array, which contains the return, the volatility, and the Sharpe ratio. And lastly, we're going to find a function containing the inverse Sharpe ratio. The reason we want to get the inverse Sharpe ratio will be explained later, but basically what it does is it allows us to minimize it much easier. For SciPy, which is a library which we'll be using, maximizing a particular thing like a Sharpe ratio is harder than just minimizing it by itself. So that's why we're going to find the inverse Sharpe ratio, and then we can minimize later, as you can see here. Then we're going to write some constraints, which basically checks if the sum is 0, if the sum is 1, and then we can obviously check the bounds, and we have the initial guess here. And then we just plug all of it in to this particular command here provided for us by SciPy. And the method is just a sequential library, which basically allows us to perform this little bit of a function here, and then we have the results here. And then what it will do is it'll print the optimal results, and it'll take a look at everything here. And we can also plot it against the S&P 500, so we have a little bit more of an easier and better understanding of how everything works and how much better our portfolio actually is. Alright, now I'll be showing an output of the actual code.